Hello all. I'm going to present a survey on ontology visualization methods by Ketafori. Let's get started. How would you like if your files were placed and stored like this? Or like this? How easy would it be to retrieve a piece of information from this clutter or a pile? Now, how would you like if it was neatly organized like this? Or like this? Any information you wanted to look up was categorized and stored in an organized way and easily accessible like in a tree-like file explorer in Windows or Mac. A very simple but powerful strategy to have folders, subfolders or categories or subcategories and files associated with them. Please note how they are viewed with an indented space for each new sublevel. From the above example, we realize the need for effective information retrieval, and for this purpose, we take advantage of an ontology. Several ontology visualization methods for visualizing huge amounts of documents are presented and evaluated in this survey. Before we move into more details, let's discuss what an ontology is. An ontology denotes a set of concepts and their interrelations in a specific domain. It is an explicit specification of conceptualization. Conceptualization is defined as abstract, simplified view of the world which needs to be represented for some purpose. It contains formal, explicit descriptions of objects, concepts, and other entities, and the relations that hold them. A more mathematical definition is given as following. An ontology is a triple, O equals C, S, ISA, and also I, where C is a set of classes where each class refers to a set of real-world objects which are classed instances. S is a set of slots where each slot could refer to a property of a class or a binary typed role, the representation of a relation between classes. Slots or properties of each class describe various features and attributes of the class, and also the restriction on slots that state conditions that must always hold to guarantee the semantic integrity of the ontology. Then the ISA is the set of inheritance relationships defined between classes. Inheritance relationships carry subset semantics and define a partial order over classes, organizing classes into one or more tree structures. And then finally, the I is the set of instances of some class. The instance includes a concrete value for each slot associated with the class or its ancestors. Let us try to get a better understanding of classes and its instances. For example, we may say that a car is an abstract concept or a model after which, say, a Mercedes-Benz or BMW is designed. These are actual instances of a car where all the properties or slots of a car, such as steering wheel, car seats, tires, etc., are implemented. Furthermore, a vehicle may be a superset of cars and indicate inheritance relationship. We can understand ontology better with the vehicle ontology example. Here we have several concepts and relations among them, as we can see from the diagram. We have concepts such as vehicle, car, bicycle, wheel, engine, model year, license number or license plate. Then we have sub-concept hierarchy such as a car is a sub-concept of vehicle. So every car is also by definition a vehicle. Then we have instance part hierarchy such as cars consist of wheels, an engine, And so every car has wheels and engine. Properties such as a car has a model year. As you can see, there are many symbols used to visualize the ontology. We can see this key associated with it. Here, the ISA inheritance relationships are organized using an unfilled arrow at the top. Now that we have a better idea of what an ontology is, let's delve into different ontology visualization methods. We will explore their characteristics and the recommendations made based on the evaluation of their characteristics and features. Such an overview of techniques is useful for choosing an ontology visualization for a specific application, taking into account both functional and non-functional requirements such as navigation capabilities or ontology size, as well as the tasks that are related to the specific domain. Now, for a method to be eligible for the visualization of an ontology, it has to support the presentation of ontology ingredients, classes, relations, instances, properties, ISA relations, and a few more. The specific user tasks that the visualization method is expected to support are important when evaluating the efficiency of an ontology visualization method. The analysis recommends following general tasks: to be able to see an overview, zoom or filter or prune, expand on details on selections by user, see relations between classes, view history, and finally extract information. We will take a closer look at the following ontology visualization methods. The visualization techniques can be grouped based on different characteristics: interaction technique, the functionality supported, or visualization dimensions such as 2D or 3D. We have following groups: indented list, node, link, and tree, zoomable, space filling and focus with context and distortion, and finally 3D information landscapes. We will now view the available methods in each group. Few things to note about 3D visualization methods is they may be resource intensive and demand increased system resources in order for smooth navigation and viewing. As a result, probably not suitable for web use. Also, since 3D methods presented here employ complex navigation methods, it may be frustrating or disorienting for a novice user. Now we move on to the indented list group, which has Protege, OntoEdit, Count, and Ontorama, which offer a Windows Explorer-like tree view of the ontology. In this view, the taxonomy of the ontology is represented as a tree. This is a snapshot of how the Protege class browser organizes ISA inheritance relationships using an indented and expandable and retractable tree. Also, the instances are displayed in a separate window. As you can see in the terms of feature support, the classes and the instances and their taxonomy and properties are supported, but the role relations are not supported in the Protege class browser. Now we will discuss the next group of ontology visualization methods, which is node, link, and tree. In this category of techniques, the ontologies are represented as a set of interconnected nodes, such as a directed graph with labeled links. The taxonomy is presented with a top-down or left-to-right layout. The main addition and features here is that the user is allowed to expand and retract nodes and their subtrees. This enables user to control the detail of the information shown and avoids display clutter. These are some of the visualization techniques covered under node link and tree category. OntoViz is a 2D Protege visualization plugin used along with the Graph Viz library. The ontology is presented as a 2D graph with the capability for each class to present, apart from its name, its properties and inheritance and role relations. As you can see, the instances are displayed in different colors and role relations are represented with links labeled with properties. It is possible for the user to choose which ontology features will be displayed as well as prune parts of the ontology. The user also has the ability to zoom in and zoom out. OntoSphere has the next 3D method is OntoSphere, which has 3 different views based on the information they display. The root focus scene, which shows a sphere with a collection of the upper level classes represented as small spheres. Second is the tree focus scene, which shows the selected class with its subtree. And third is the concept focus scene, which shows all the information about the selected class, like ancestors, children, and semantic relations. As you can see that the color and the size coding is used to denote the existence of subtrees and their size. So the bigger the sphere, then bigger is the subtree. Please note that the OntoSphere does not visualize the taxonomy, but the direct role relations between classes. In this table, we can see that properties is not represented in OntoSphere. Let's move on to the third ontology visualization group, the zoomable visualizations. Here is the list of few of the methods. Grokr is a system for the display of knowledge maps. It offers graphical representation of information like the results of a search engine or a file search explorer. The clustering mechanism presents the documents as a series of nested Venn diagrams. When a circle is selected, it is magnified with the use of animation to make its contents visible. Here, the classes are represented as colored circles. Lower level nodes are smaller in size, as you can see, and nested inside their parent nodes. In 3D zoomable, we have information pyramids, where the hierarchy is represented as pyramids that have a flattened top. The subcategories are placed on the top of the broader category pyramids as smaller ones, and if the category contains leaf nodes, they are represented as small rectangle objects. As you can see, each pyramid is a layer with the lower level nodes on top of it, and the layout is recursive. The Grokr and information pyramids do not display multiple inheritance or role relations, and the properties are displayed in a separate window. Now we will take a look at our fourth category of ontology visualization methods, which is space filling techniques. The ones we will discuss here is tree maps, which is used for visualizing gene ontology. The tree maps visualization method uses the 2D approach of space filling to represent hierarchies using a rectangular area with rectangular subdivisions. As you can see, it is used as a tool to visualize gene ontology. Tree maps uses labels, size, and color for different gene attributes and to evaluate data. The user can zoom on details and make query data. In terms of feature support, it does not support multiple inheritance or role relations. Next, we discuss our fifth group of methods, the context with focus and distortion techniques. This group of techniques is based on the notion of distorting the view of the presented graph in order to combine context and focus. And a hyperbolic equation is usually used to achieve that. We discuss one of the methods, 3D hyperbolic tree. The 3D hyperbolic tree visualization was created for website visualizations, but has also been used as a file browser. The classes are represented as nodes placed on the surface of a sphere, with visible labels on the ones closest to the one on focus in the center, which is usually in the center. As in the picture, the node on focus is the central one, and the rest of the nodes are presented around. Note that reduced in size. The lower level nodes are displayed further away from the one on focus and with smaller size. In terms of feature support, it does not represent properties. The last group of methods is information landscapes, where documents are placed on a plane as color and size coded 3D objects. So you will see different 3D objects with different colors and sizes as the classes and instances. The file system navigator system was created as a 3D file explorer for Unix systems. In case of Harmony Information Landscape, it was designed for hypertext documents. As you can see in this picture, the nodes are arranged directly on the plane. Also note how the hypertext relations are represented using lines connecting a selected node to its related nodes. In terms of feature support, multiple inheritance is not supported, but this method is considered very useful for representing role relations. Following is the list. Finally, we have the list of advantages and disadvantages of the methods discussed so far by the authors. The indented list offers simplicity, and it has systematic exploration, but it suffers from poor space filling, and the support for role relations is missing as well. In the second case with node link tree, it is intuitive and the hierarchy in the width and the depth is easily distinguishable. But it makes inefficient use of screen space, leading to cluttered displays when the number of nodes is large. Then we have zoomable, which seems successful for browsing to locate specific nodes. However, they do not offer an effective overview of the hierarchy. Then, space-filling methods are suited for tasks that include overview of properties and areas with many or few nodes, but are not effective for structure-related tasks such as level and sibling detection. In the case of focus with context distortion, the advantage was the dynamic handling and the positioning of nodes, while its main drawback was the lack of stability of the context area when the focus node changed. Finally, for 3D information landscapes, they are effective for hierarchy overview related tasks. However, for huge subtrees, it creates a wide layout that cannot be seen all at once, and as a result, it is not possible to retain global context. That is the conclusion. Any questions?